Hello and welcome to my channel. In this video we are going to solve some classic and basic examples based on integration by substitution, also called as u-substitution or reverse chain rule. Now in this video we are going to focus on linear substitutions like u is equal to ax plus b. So this is the list of questions which we will be discussing soon. So there are total 5 indefinite integral questions and 1 question on definite integrals. So if the limits of the integral is given, we call them as definite integrals. So let us start with the first question now. The first question is integrate x plus 3 raised to 4 dx. Now we have to integrate this given function using substitution. And we can see that x plus 3 is of the form ax plus b, with a being as 1 in this case and b as 3. Since this is a linear expression given raised to the power of 4, let us substitute x plus 3 is equal to u. So this is our step number 1, that is let u is equal to x plus 3. So we are going to ignore the power. Now once we have done this, we are going to differentiate both the sides of the equal to sign with respect to x. So differentiating u with respect to x gives us du by dx is equal to, now differentiation of x is 1 and differentiation of a constant with respect to x is 0. So the differentiation of x plus 3 gives us 1. Now once we have got this, let us take dx on the other side of equal to sign and multiply it by 1. So this is our step number 1, that is substituting u equal to x plus 3. This is our step number 2, that is differentiating both the sides with respect to x. And this is our step number 3, that is taking dx on the other side of equal to sign. So here du will be equal to, now 1 multiplies with dx giving us dx. So du is equal to dx. Now once we have got this, let us start with the substitution in the main function given. So integration of x plus 3 raised to 4 dx is equal to integration of, now in place of x plus 3 we have written u. So u to the power of 4. Now in place of dx we are going to replace du. So you can observe that all the x terms are being replaced by u terms. So once we have got all the x terms replaced by u, we are going to integrate this indefinite integral. Now to integrate u to the power of 4, we have to make use of power rule of integration, which is integration of k times x to the power of n dx is equal to, now here k represents a constant like 1, 2, 100, 200 and so on. So when we are integrating a constant which is being multiplied with x to the power of n, then that gives us this constant, the k comes out, times x to the power of, now this power n increases by 1, giving us x to the power of n plus 1 over the same power comes to the denominator, giving us x to the power of n plus 1 over n plus 1. And since this is an indefinite integral, as the lower limit and upper limit is not given, we have to write plus c, where c represents constant of integration. Now here if we see, we have to integrate u to the power of 4. So in place of x we have u and the constant here is going to be 1. So if there is no number, it's going to be default 1. So here using this formula we have written u to the power of, now the power 4 increases by 1 giving us 4 plus 1 as 5 and the same power comes to the denominator. So integration of u raised to 4 gives us u to the power of 5 over 5 plus c. Now one last step is replacing u by its original function, that is x plus 3. So here we get, in place of u we have written x plus 3 to the power of 5 over 5 plus c. So this is the answer for the integration of x plus 3 to the power of 4 dx. Now let us move on to the next question. Integrate square root of 4x minus 5 dx. Now 4x minus 5 is of the form ax plus b, where a is 4 and b is negative 5. So since the expression under the square root is a linear expression, we are going to use u is equal to ax plus b substitution. So this is our step number 1. Let u be equal to 4x minus 5. Now once we have got this, the second step is differentiating both the sides of the equal to sign with respect to x. So u becomes du by dx is equal to differentiation of 4x gives us 4 and differentiation of a constant which is -5 becomes 0. So differentiation of 4x minus 5 gives us 4. Now step number 3 is making dx as the subject. So we are going to take dx on the other side of equal to sign and 4 is going to take its place, giving us 1 over 4 times du is equal to dx. Now once we have got all these, now we have to substitute these terms in the main function. So integration of square root of 4x minus 5 dx will be equal to integration of square root of, now in place of 4x minus 5 we have replaced u times, now dx is being replaced by 1 over 4 du. Now 1 over 4 is a constant, so we are going to take it out of the integration sign. So we get 1 over 4 integration of, now square root can be written as a fractional power. So here we have written u to the power of 1 over 2. So square root is being written as 1 over 2 du. Now again we have to use the power rule of integration since this is of the form x to the power of n. So we get 1 over 4 times, the integration of u raised to 1 over 2 gives us u raised to, now the power 1 over 2 increases by 1 giving us 1 plus 1 over 2 and the same power repeats in the denominator giving us 1 plus 1 over 2 plus c, since this is an indefinite integral. Now simplifying this we get 1 over 4 times u to the power of 1 plus 1 over 2 is 3 over 2 over 3 over 2 plus c. Now let us take this fraction to the numerator. So we get 1 over 4 times. Now when this fraction comes to the numerator, it flips upside down. So 3 over 2 now becomes 2 over 3 times u to the power of 3 over 2 plus c. Now 2 divides 4, that is 2 1 times is 2 and 2 2 times is 4. So this simplifies as, in the numerator we have 1 over 2 times 3 is 6 times, now replacing u by the x term, we get 4x minus 5 raised to 3 over 2 plus c. So this is the answer for the given integration. Now let us move on to the third question. Integrate cos 2x plus 3 dx. Now here 2x plus 3 is within the cos function and we can see that 2x plus 3 is of the form ax plus b. So here again we are going to use u is equal to ax plus b substitution, giving us u is equal to 2x plus 3. So this is our step number 1. Step number 2 is differentiating both the sides of the equal to sign with respect to x. So this is going to give us du by dx is equal to derivative of 2x is 2 and derivative of plus 3 is 0. So du by dx is equal to 2. Now the next step is making dx as the subject. So dx goes on the other side of equal to sign and 2 takes its place, giving us 1 over 2 times du is equal to dx. Now we are going to replace all the x terms by u terms in this expression, giving us integration of cos 2x plus 3 dx is equal to integration of cos, now 2x plus 3 is being replaced by u times, now dx is being replaced as 1 over 2 times du. Now 1 over 2 is a constant, so we have taken it out of the integration sign, giving us 1 over 2 integration of cos u du. Now integration of cos u is sin u, so we get 1 over 2 sin u plus c. So this is a direct application of integration of cos u, which gives us sin u. So here if integration of sin was given, then we would have got minus cos of the given function. So here we get 1 over 2 sin u plus c. Now replacing u by the x terms, we get 1 over 2 times sin 2x plus 3 plus c. So this also gives rise to a general formula, which is integration of cos of the form ax plus b dx will be equal to 1 over a times sin ax plus b plus c. So this is the first formula which can be useful in solving these kind of questions. And the second formula is if we have replaced cos by sin. So integration of sin ax plus b dx will be equal to minus 1 over a cos ax plus b plus c. So integration of cos is sin and integration of sine is minus cos. So these are the two formulas which you can remember for these kind of questions. Now let us move on to the next question. Integration of 1 over 1 minus 7x dx. Now here the denominator is of the form b plus ax, where b is 1 and a is negative 7. So let us take u is equal to 1 minus 7x. So this is our step number 1. Let u is equal to 1 minus 7x. Step number 2 is differentiating both the sides of the equal to sign with respect to x. So this gives us du by dx is equal to negative 7. Now the third step is making dx as the subject. So dx goes on the other side of equal to sign and negative 7 takes its place, giving us negative 1 over 7 du is equal to dx. Now let us replace all the x terms by u terms. So integration of 1 over 1 minus 7x dx will be equal to integration of 1 over 1 minus 7x becomes u times dx is equal to minus 1 over 7 times du. Now taking the constant outside the integration sign, we get negative 1 over 7 integration of 1 over u du. Now we have a direct formula for integration of 1 over u form, which is ln absolute value of u. So here we get minus 1 over 7 ln absolute value of u plus c. Now replacing u by the x terms, we get negative 1 over 7 ln absolute value of 1 minus 7x plus c. So this is the answer for the given question. Now there is a direct formula to integrate these kind of questions where we have a linear expression in the denominator. So the formula is integration of 1 over ax plus b dx is equal to 1 over a ln absolute value of ax plus b plus c. So to solve these kind of questions, you can also use this direct formula. Now let us move on to the next question. Integration of e raised to 3x minus 2 dx. Now here we can see that the power of e is in the form of ax plus b, where a is equal to 3 and b is equal to negative 2. So let us consider u is equal to 3x minus 2. So let u is equal to 3x minus 2. Step number 2 is differentiating both the sides of the equal to sign with respect to x. So we get du by dx is equal to 3. Now step number 3 is making dx as the subject. So taking dx on the other side of equal to sign, 3 will take its place, giving us 1 over 3 times du is equal to dx. Now let us replace all the x terms by the u terms. So integration of e raised to 3x minus 2 dx will be equal to integration of e to the power of u times dx has been replaced as 1 over 3 du. Now taking 1 over 3 outside the integration, we get 1 over 3 integration of e to the power of u du. The integration of e raised to u gives us e raised to u itself. So here we get 1 over 3 times e raised to u plus c. Now replacing u by the x terms, we get 1 over 3 times e raised to 3x minus 2 plus c. So this is our answer. Now moving on to the last question. Integration of 8 plus x to the power of 2 dx from x is equal to 1 to x is equal to 3. So 8 plus x is of the form ax plus b, where a is 1 and b is 8. So let us take u is equal to 8 plus x. Step number 2 gives us du by dx is equal to differentiation of 8 is 0 and differentiation of x is 1. So du by dx equal to 1. Now taking dx on the other side of the equal to sign, we get step number 3, that is du is equal to dx. Now replacing all the x terms by u terms, we get integration of x is equal to 1 to x is equal to 3 of 8 plus x to the power of 2 dx is equal to. Now since this is a definite integral, remember that the limits over here also needs to be changed from the x terms to the u terms when we are replacing all the x terms by u. So here for the lower limit, when x is equal to 1, we get u is equal to 8 plus 1. This is going to give us 9, and when x is equal to 3, we get u is equal to 8 plus 3, giving us 11. So the lower limit and upper limit now becomes 9 and 11. Integration of u square du. Now this is of the form x to the power of n. So we are going to use the power rule of integration to integrate this term. So we get u to the power of, now using the power rule of integration, the power of u increases by 1. So 2 becomes 3 over 3. Now the upper and lower limits are 11 and 9. So we don't have to write here plus c because this comes under definite integrals. Now in the next step we have taken the constant out, that is 1 over 3, and we have written u to the power of 3 with the given limits. Now in the next step we are going to substitute the value of upper limit minus the lower limit in the place of u. So this gives us 1 over 3 times 11 to the power of 3 minus 9 to the power of 3. So this is going to give us 602 over 3. So this is going to be our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.